Hi guys, this is Tobias, TS3MHT, and today we look at my poor man's version of a Stream Deck that I hacked together about a month ago. Pretty straightforward design, tiny 2040 microcontroller, so it's a Raspberry Pi Pico variant, one of these small 128x32 pixel OLED displays and 6 buttons. So if you're interested how I hacked this together and how it works, stick around. Okay, so before we jump into how the hardware is wired up, let's have a quick look how it works so that you get an idea what it does. Okay, so let's look at the hardware. Okay, so I've drawn all the individual bits that we need so far. The RP2040 or the tiny 2040 is of course simply connected to the OLED display. So I decided to hook up the OLED display to the 5 volt line because I know that my display has a voltage regulator 5 volt to 3.3 volt on. So I'm not sure what happens when I directly hook it up to 3.3 volt. Probably works as well. But anyway, I decided to use the 5 volt line. Obviously we need ground, and yeah, I'll take the ground this way around, also connecting one side of all the buttons to ground. Then obviously the I2C connection. Let's see how nasty the drawing will get. Maybe like this. And yeah, if your OLED display has internal pull-ups, you can stop here and it will work. But I know for a fact that I've taken off the pull-ups on my OLED display because I've used it for something else before. So I had to basically add the pull-ups that I've removed from the back side of the OLED display back in again. And yeah, it's straightforward. 10K pull-ups go to 3.3 volt. And yeah, nothing special here about hooking up the OLED display. Okay, now the buttons are maybe a little bit more complicated. First you might wonder why I used 2 analog inputs and not a single one. And the reason is that I'm also having an ICOM IC705 ham radio transceiver, and you can hook up a keypad to the transceiver, and I think it's used for Morse code or playing back voice memos. So basically you can hook up a small external keyboard with up to 8 buttons and trigger certain events on the ham radio transceiver. And I thought, hey, if I'm building this, maybe I can make it dual use. If I connect a 3.5mm jack, then I could basically use these 3 connections to connect it to the ham radio transceiver. And this is mainly the reason why the schematic looks like this. So this is shamelessly stolen from Ham Radio Workbench website. I'll put the link below. And you are wondering, okay, 6 buttons, you just said you can hook up 8, and that's true, but 6 was all that I had in my parts box. In theory, you could basically duplicate the schematic for the first 4 buttons and basically add 2 more resistors here and 2 more buttons here, and then you can basically hook up yeah, switch number 7 and switch number 8 as well. And of course the resistors are the same 2.2K, 4.7K. But as I said, I only had 6 of these nice red vintage buttons in the parts drawer, so 6 it is. Okay, now another question you might ask yourself, why am I doing this with this resistor network, and why I'm not just hooking up the buttons directly to a GPIO pin? And I could have done that. I think, yeah, I would have had 6 spare GPIO pins, so I could just say, okay, well, 6 buttons, 6 in quotes wasted GPIO pins just for detecting a button press. And of course it's nicer to just have a single wire used for all these buttons. And in theory I could have hooked up all the 6 buttons to a single ADC input. But due to the dual use idea of using the ICOM IC705 as a plan B, I decided, yeah, the button layout or the resistor network has to look like this in order to be compatible with the IC705. And that's basically the reason why I need 2 analog inputs. Well, so obviously they are connected like this. But yeah, as it's an analog input, I also need pull-ups again. So there's 2 more 10K pull-up resistors on this side, similar to the I2C bus. So they also go up here. And there you have it, yeah? 4 pull-up resistors, each 10K. And now when any of these buttons is pressed, a different voltage is given to ADC input 0 or ADC input 1. And I can easily detect that in software. The drawback, of course, is that, well, all the buttons connected to a single ADC input, you can only detect 1 button press at a time. So you cannot do something like, you know, detect 3 pressed buttons or detect 4 pressed buttons at once. Because, yeah, if you look here, if S1 is closed, then this one is already shorted to ground. So basically everything that comes afterwards doesn't really matter, yeah? So basically, priority-wise, S1 has priority over S2, S2 has priority over S3, S3 button press has priority over S4. And then the same is basically true for the remaining buttons here. S5 has priority over S6. And if I would have put in S7, S8, well, basically the same as for the first 4 buttons. So if you would want to detect 2 buttons at once, that would just work basically for detecting 1 of S1, S2, S3, S4, and then 1 of S5 and S6 at the moment. So I could do something like, you know, Shift A, B, C, D, or Control A, B, C, D. I mean, you get the idea. Pretty straightforward. Yeah, and the software looks equally simple. So let's jump right into it and have a look at the software. As you have seen, I'm using the Tiny 2040 here, which is a Raspberry Pi Pico variant. And I decided to use CircuitPython to slap together this prototype. And the benefit of CircuitPython is that it supports a USB HID device, so USB human interface device, so you can simulate a keyboard and mouse. And this is exactly what I need for this poor man's version of Stream Deck. So usually when you start or flash the CircuitPython, the system is always booting up here with a USB drive, and you can just directly copy your code on. Usually, well, code.py is your main Python entry function. And then you can also obviously put libraries into the lib folder. So as you can see here, I used the Adafruit HID device to simulate the keyboard. And then I put the Adafruit Display IO SSD1306, SSD1305 display driver, because I didn't know which one worked better. I think 1306 works fine on my eBay bought OLED display. And yeah, then you can basically start hacking away. In the background you see I've just downloaded Tony. I don't know how you pronounce that. Tony, I don't know. which basically gives you the option to run the current script and to stop. And it also has the interactive console. So you basically can, if you're playing around with it and try to figure out, hey, I want to switch that LED on, read that GPIO port, you can just directly type here the Python commands into the console and see if it works. And then once it works, you just drag your code snippet up there into your actual code, and you can save it. So it's a very nice, quick and simple way to prototype your hardware. What else do I want to say? Yeah, as I've just said, the CircuitPython usually comes up here with this USB device, and with your Stream Deck, with my Stream Deck simulation, I don't always want to see that USB device. So there's an option to create a boot.py, and in that boot.py function you can import storage and call storage disable USB drive. And if you reset your Raspberry Pi Pico Tiny 2040, then the USB drive does not show up. But sometimes it's nice to show up. So what I've actually done is I'm just reading here the ADC 0. And when the ADC value is bigger 60,000, which basically means no buttons pressed, then I disable the USB drive. And when you hold one of the buttons, button 1, 2, 3, 4 during boot up, then the ADC value will be smaller than 60,000, and it will not disable the USB drive. So yeah, that's a pretty easy, nice hack to basically decide, do you want to have this USB drive or not? And then of course we have the main code, which is pretty straightforward. I'm not claiming this is polished, finished, pretty or anything. It does its job, and maybe this is as far as I take it at the moment, and I just start using this thing. So how does it look like? Okay, we have a while loop that is executed forever with a 100 millisecond interval. I'm reading the buttons via the ADC. Nothing special here. Get button, yeah, pretty primitive. Just if the ADC value is smaller, then I assign different buttons. Okay, we have 6 buttons, and if the default case is obviously no button pressed, and then I set it to button key release. So get button gets you the currently pressed button. Then I compare the currently pressed button with the previous pressed button, because you probably do not want to constantly send the same key commands while the button is being held down. Obviously, we need to do something with the red button there if the button has changed. So either it's pressed or released, or we went from button 1 to button 3, etc. So there's a handle button routine which sends the different key events, which can be done very easily with the Adafruit HID library. So keyboard press, and then you just give it an array of or a list of keys. I decided to just say control 1, control 2, control 3, control 4, 5, 6. And when the buttons are released, then I'm calling keyboard release all. Again, I'm not saying that's the perfect way to use this library. I really prototyped this thing within, I think, 3 days of spare time. So not 3 days full work, but I don't know, maybe how many hours? Maybe 6 hours work or so. And right, so I'm handling the keyboard events. I'm reading the ADC to get the currently pressed button. I'm handling the button event by sending the USB key press events. Then I have another function that handles the LED. There's a RGB LED on the Tiny 2040. So whenever I press one of these 6 buttons, it shows a different color. And then we have the OLED display, and yeah, I'm not really familiar with that OLED library. It seems to be very powerful and be made for like much bigger displays, multiple colors, drawing bitmaps, etc. So it's a bit overkill for the SSD 1305, 1306. Anyway, I based on the button press, I query what text I want to display, and I made the text sticky, so even after the key is released, the text stays set in the display and doesn't disappear on key release. So that's why it says here if text, because the key release returns an empty string, and then it basically would immediately clear the display. So what do I do here? Well, I remove the previous text, then I draw, well, a text label with the new text, and then I add it to the display I/O driver. As I said, I've really not fully understood the display I/O driver. It is a bit overkill for this tiny display, but hey, it works. Okay, and as a last step, I'm storing the currently detected button in a previous button variable. And yeah, that's basically all the code, and everything at the beginning is just, okay, there's this utility function to set the LED, to get the button, handle the LED, get the display text. And yeah, why does that still say key? I think in my video before I had it changed to scene 1, scene 2, scene 3, scene 4. Not sure why it shows here key again. Maybe it's an old file. Let me try to open it again from the USB drive. Is that now something else? Yeah, now we have the current code. Sorry, it had some old code in the editor. So here you can see this is the text that was shown when I pressed the different buttons. Okay, initializing the ADC, initializing the USB HID keyboard, and initializing the PWM for this RGB LED. Okay, and obviously initializing the display. So as you can see, really nothing special or nothing that cost a huge amount of time. Everything was already there, provided by CircuitPython. So I'm just using the libraries that are available, and yeah, very easy to get a poor man's Stream Deck going with limited time effort. So I'm quite happy with the result so far. Of course, it would be nice to print a case, spend some time with some I don't know, with Fusion 360 and create a nice case for it. Let's see if I do that, or if I just put this thing as is on my desk and use it for the next live streams. Okay, so I'm already talking again since 10 minutes, so thanks for watching, and until next time. Bye!